9 of the test 4 review, Physics Bootcamp. Question 9 says a force of 3.5 newtons is exerted on a negative 2.3, and then this symbol here is micro coulomb charge. Micro means 10 to the minus 6. Milli means 10 to the minus 3. Nano means 10 to the minus 9. Pico means 10 to the minus 12. Often in electricity, charges are very small, so we use these symbols. So micro is 10 to the minus 6. Charge in an upward direction. So we have this charge, negative 2.3 microcoulomb, and there's a certain electric field there, right, set up by something, and then that electric field is exerting a force of 3.5 newtons in the upward direction. Okay, so that's the force. F equal 3.5 newtons up. What is the magnitude and direction of the electric field at this point, right? So all of a sudden, if I take away this negative 2.3 microcoulomb charge, is there going to be any electric field remaining there? The answer is yes, because that electric field is set up by some other source. It could be a single charge, it could be a multiple of charges. So some other source is setting up that electric field independent of the existence of this charge, right? So what is the magnitude of that electric field if I take this charge away? So we said in the previous video, E equals F over Q, right? Or F equals EQ, right? In this case, we know the F, so we say F over Q is E, and then F is equal to 3.5 newtons up, right? As given by the problem. Q is equal to negative 2.3, and then micro is 10 to the minus 6, right? Well, if I divide 3.5 by 2.3, I get about 1.5. And then since you have 10 to the minus 6 on the bottom, it goes up to the numerator and becomes 10 to the 6th. Now, what happens to the direction? Notice there's a negative here. If the force was up and there's a negative, then the negative makes the up a down, right? So that means the electric field is down. So the magnitude of the electric field at that location is 1.5 times 10 to the 6th, and the direction is down, so the answer is this one. 1.5 times 10 to the 6th newtons downward. If you didn't take into account the micro, you would have said 1.5 newtons downward, right? If you didn't take into account this negative, someone might have put the choice A, 1.5 times 10 to the 6 newtons upward, right? So you have to be careful, take into account the micro, take into account the direction. So the summary of what's happening here is there is originally an electric field set up by some source. It could be some positive charges here that are setting this up. Then somebody comes and places a negative 2.3 microcoulomb charge there, right? Which direction will that charge want to move? Okay, in the previous problem we said negative charges like to move opposite the direction of the electric field, right? That's because they experience a force opposite to the direction of the electric field, right? So the force on it is this way, up. That makes it go opposite to the direction of the electric field. So you see the force, 3.5 newtons, and it's upward. So it's going to go that way. So the original electric field has to be what? Downward. Okay? So now you can see and visualize what is happening in the problem. Thank you.